Good morning, children. Now we'll learn about the direction ratios. What are these direction ratios? You have learned about the direction cosines. So you have seen some examples like this. See, you have 2 by 7, 3 by 7, and then minus 6 by 7 as the direction cosines of a line. So these are L, M, N. And you have the property that L square plus M square plus N square is equal to 1. So you can see 4 plus 9, 4, 9 and 36. 49, 7 by 7 is equal to 1. So they are satisfying. This is one set of direction cosines. Okay. Now direction ratios means any ratio which is proportional to direction cosines, are called as direction ratios. So if you multiply all the 3 by 7, you will get 2, 3, minus 6, isn't it? So 2, 3, minus 6 is one set of direction ratios for this line. So 2, 3, minus 6 is one set of direction ratios of the line whose direction cosines are these three. Now, if I multiply this by 2, I'll get 4, 6 is 12. You can see. So, these are proportional to this. When you are multiplying this by 2, you are getting this. No? So, this is another set of direction ratios. These are just the direction ratios of the same line. So, suppose that for a line, these are the direction cosines. Then they satisfy this property. Now, any set of ordered triad of real numbers which are proportional to direction cosines, any set of ordered triad of real numbers which are proportional to the direction cosines are called as direction ratios. So, for a line, you have two sets of direction cosines, whereas you have infinite number of direction ratios. Like this, suppose I divide this by 2, then I'll get 2 by 2, and then 3 by 2, and then minus 6 by 2. This is another set of direction ratios. If I divide by 3, another number, I'll get another set of direction ratios. If I divide by root 2, I'll get another set of direction ratios. Like this, I'll get infinite number of direction ratios defined for one straight line. Whereas direction cosines are just two sets, as you know. They are L, M, N and minus L, minus M, minus N. Now, these are denoted by A, B and C. A1, B1, C1, A2, B2, C2, like that. Whereas here, the direction cosines, suppose you have two lines. The direction cosines of one line are denoted by L1, M1, N1. And the direction cosines of another line are denoted by L2, M2, N2. Then the direction ratios are denoted by A1, B1, C1 and then A2, B2, C2. These are the letters that we use. So when it is ratios, it is A1, B1, C1 like that. Now suppose A, B, C are this. So here, this type of property will not be satisfied. A square plus B square plus C square need not be equal to 1 in general. So if you take this ratio itself, if I take ABC as instead of 2, 3, minus 7, I can divide by 2, root 2 like that. Suppose I divide by 7. They also become the direction ratios. But here these three are satisfying this condition, so they become the direction cosines. So direction ratios cannot become direction cosines. But direction cosines are always direction ratios because they are just the ratios. You can cancel the denominator and write in the form of ratio. That is one set of direction ratio like that. So this is about. Now, how to find the direction ratios of a line passing through 2 points? Direction ratios of a line passing through 2 points. Or suppose that you have like similar to direction cosines, we'll find out. Suppose this is O and this is P, X, Y, Z is a point. Then what are the direction ratios of OP? This is x-axis, y-axis, and then z-axis. Oh, so according to our this thing, it is x by r, y by r, and z by r, no? So if you cancel the common ratio r, you will have x, y, z. By r, if you cancel, then x, y, z itself becomes the direction ratios of OP. So the coordinates of P themselves become the direction ratios. When it is direction cosines, you will divide by r. R is OP distance, like that. Now suppose that you have 2 points on a straight line. Then how to find the direction ratios? So suppose that you have 2 points P x1, y1, z1, q x2, y2, z2 on a straight line. Then we have direction cosines as x2 minus x1 by r, then y2 minus y1 by r, and then z2 minus z1 by r. These are the direction cosines. These are DCs. So direction ratios are, you can just cancel this r, multiply all the 3 by r will get cancelled. So you'll get x2 minus x1, then y2 minus y1, then z2 minus z2. So it is easy to find the direction ratios. For cosines, you have to divide by r. For ratios, it is just the difference of coordinates. x2 minus x1, y2 minus y1, and z2 minus z1. Okay, the next is, so next property is, okay, next is angle between two straight lines. So all this we completed. Okay. Now suppose that you have two straight lines like this, and then when you extend, they will have some angle. So how to define the angle between them? So in terms of direction ratios, we have one formula. In terms of direction cosines, we have another formula like this. So suppose that L1, M1, N1, L2, M2, N2 are the direction cosines of both the lines, and theta is the angle between them. Then cos theta is given by the formula L1, L2 plus M1, M2 plus N1, N2. That's all. This is the formula for direction ratio, formula for angle between two straight lines in terms of direction cosines. In terms of direction ratios, it is mod of A1, A2 plus B1, B2 plus C1, C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. It is similar to the formula which you have learnt in vectors and all. Okay, cos theta. So this is the where here A1, B1, C1, A2, B2, C2 are the direction ratios of the two lines. In two-dimensional coordinate system, you have A1, A2, B1, B2 only. C1, C2 won't be there. So there it is straight lines. Don't do mistakes. There the lines are A1x plus B1y plus C1 is there. There also you have lines. A1, B1, C1, A2, B2, C2 also are there. These are two straight lines in two dimensions. So the angle between them is given by the formula same, cos theta is equal to A1, A2 plus B1, B2 only by root of A1 square plus B1 square into root of A2 square plus B2 square. So in two dimensions, you have only two terms like this. C1, C2 are constants there. Okay. And then here, it is C also will be there, where A, B, C are the direction ratios. They are the direction ratios. So understand the difference between cos theta formula in two dimensions. These are two straight lines. Angle between them is theta given by this formula. So here also there are two straight lines, theta only, but A, B, C are the direction ratios. Here A, B are the coefficients of x and y. Okay, now suppose that you have the direction ratios of a line. When you have direction ratios, suppose that for a line the direction ratios are A, B, C. Then the direction cosines are given by A by root of A square plus B square plus C square, comma B by root of a square plus b square plus c square, and then c by root of a square plus b square plus c square. So that means when direction ratios are given, these are DRs. When you know direction ratios, you can find direction cosines like this by dividing all the three by root of a square plus b square plus c square. Okay, next is in the case of direction cosines, in the case of DCs, when two lines are parallel, their direction cosines are equal. We have seen one example also. Suppose they are direction ratios. So the direction ratios of first line are A1, B1, C1, and then direction ratios of second line are A2, B2, C2. And they are parallel. If at all they are parallel, then they satisfy the condition A1 by A2 is equal to B1 by B2 is equal to C1 by C2. You have similar property in two dimensions also. If these two lines are parallel, then you have A1 by A2 is equal to B1 by B2. That's all. If A1 by A2 is equal to B1 by B2 in two dimensions, then the two lines are parallel. Here the two lines are parallel if the direction ratios are proportional. So the direction ratio should be proportional like this. Now suppose the two lines are perpendicular to each other. So the direction ratios of one line are A1, B1, C1 and A2, B2, C2 are the direction ratios of perpendicular line. Then they satisfy the condition A1, A2 plus B1, B2 plus C1, C2 is equal to 0. That means this theta should be 90. Cos 90 is 0. So that means this should be equal to 0. So like that also you can remember. So when two lines are perpendicular, then this product should be equal to 0, where A, B, C are the direction ratios. Now in the case of straight lines also, when these two lines are perpendicular to each other, then they satisfy the condition A1, A2 plus B1, B2 is equal to 0. That's all. In three dimensions it is this, but these are the direction ratios. And here they are the coefficients of x and y accordingly. Okay, now we'll summarize and write all these points. Yes. So what all we have learnt, we'll write as points. So any three real numbers which are proportional to direction cosines are called as direction ratios. Any three real numbers which are proportional to direction cosines are called as direction ratios of that line. Now if A, B, C are the direction ratios, these are all like note points. From this definition you will get all these points. So when you multiply these direction ratios with any number lambda, where lambda is not equal to 0, then all of them becomes the direction ratios of the same line. So a line have infinite number of direction ratios. Now if A, B, C are the direction ratios, then that condition A square plus B square plus C square need not be equal to 1 in general. Okay, then direction cosines of a line are direction ratios. Direction cosines can be considered as ratios, but ratios cannot be cosines always. Now if A, B, C are the direction ratios, when you know the direction ratios, you can find the direction cosines using this formula. We need this in some problems, so understand. Now when two points, suppose that on a line there are 2 points given, then you know how to write the direction cosines. x2 minus x1 by r is there, like that. But here it is ratios only, no? So just x2 minus x1, y2 minus y1, z2 minus z1 become the direction ratios of that line. Now suppose that P is a point anywhere in the plane, and then O is the origin. Then the direction ratios are just x2 minus x1 means x minus 0, y minus 0, z minus 0. That means the coordinates themselves becomes the direction ratios. Now the angle between two straight lines in space is given by, so suppose you have x-axis, y-axis, z-axis, and then angle between them. Suppose you have like this, x, y and z-axis. Two straight lines are there. You must find the angle between them. So they are in the space. So what you do is draw a line parallel to it and passing through origin. Suppose you have another line. Draw a line parallel to it and passing through origin. Then the angle between those two will be the angle between this line and another line in the space, like that. So like this we define the angle between two lines. Now we'll write the formula for angle theta between the two lines when direction ratios are given and direction cosines are given. So suppose that L1 M1 N1, L1 M1 N1 and L2 M2 N2 be the direction cosines of two straight lines respectively. Then if L be the two straight lines respectively, let theta be the angle between them. Then you have the formula cos theta is equal to mod of L1 L2 plus M1 M2 plus N1 N2. So that means theta is equal to cos inverse of mod of L1 L2 plus M1 M2 plus N1 N2 like this. Now next you have another formula for sin theta and also for tan theta. Sin theta is root of sigma of L1 M2 minus L2 M1 whole square. So all the three terms whole square is sin theta. And then tan theta is sin theta by cos theta, no? So it is root of sigma of L1 M2 minus L2 M1 whole square by mod of L1 L2 plus M1 M2 plus N1 N2. Okay, next third point is if the lines are parallel, then their DCs are equal. Then L1 M1 N1 is equal to L2 M2 N2 like this. And then if the lines are perpendicular, then the condition is L1 L2 plus M1 M2 plus N1 N2 is equal to 0. So this is about the direction cosines. Now suppose that A1 B1 C1 and A2 B2 C2 be the direction ratios of two straight lines respectively, and theta be the angle between them, Then you have the formula. Then first one, same way, theta is equal to cos inverse of mod of A1 A2 plus B1 B2 plus C1 C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. So here if you take L1 square, M1 square and so on, it will be 1. So because of that, it is just this formula. Okay, next second formula is tan theta. So sin theta formula is not given. So tan theta formula is given as root of sigma of A1 B2 minus A2 B1 whole square by mod of A1 A2 plus B1 B2 plus C1 C2. Okay, here it is modulus. Now, in the same way, if the lines are parallel, then the condition is, then you have A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Now, if the lines are perpendicular, then the condition is A1 A2 plus B1 B2 plus C1 C2 is equal to 0. So these are the formulae relating to direction cosines, and those are for direction ratios. Now in the questions, you will be given some terms like this, one sentence like this. So when direction cosines are proportional to, when the DCs are, there are some problems where you come across this type of thing, are proportional to. The direction, when direction cosines are proportional to some number, he gives like this, then it means that these are the direction ratios. It means that DRs, direction ratios, are 3, 4, 5. So just don't just see this word direction cosines. See what it is. When it is direction cosines, don't just take them as direction cosines. Read the complete sentence. Direction cosines are proportional to means they are the direction ratios. So this is one point that you should observe in solving the problems. Okay, now we can do the next exercise problems. We'll do few simple problems. Okay, first problem, find the direction ratios and direction cosines of the, these are all example problems. First one, find the DRs. Find the DRs and DCs of the line joining the points, 4 minus 7, 3, 6 minus 5, 2. So in the solution, so first you should know how to find the direction cosines and direction ratios. Then it becomes easy. Problems are all very easy. So you take the point A as x1, y1, z1, that is 4 minus 7, 3. And then B as x2, y2, z2, that is 6 minus 5, 2. So x2 is 6 like that. So what are the direction ratios? DR's formula is just x2 minus x1, y2 minus y1, and then z2 minus z1. Just to subtract x2 minus x1, x2. 6 minus 4, 2. Minus 5 minus of minus plus 7, 2. And then 2 minus 3, minus 1. Like this. Now you find AB distance, or you know direction ratios, no? So what are DCs? So DCs are 2 by root of 2 square plus 2 square plus minus 1 whole square. So when DRs are known, you can find DCs directly like this. Again, you need not go for x2 minus x1 by r like that. Directly you write 2 by root of 2 square plus 2 square plus minus 1 whole square. And then minus 1 by root of 2 square plus 2 square plus minus 1 whole square like this. So 4, 4, 8, 9. So that is 2 by 3, 2 by 3 and minus 1 by 3. So like this we find the direction ratios and direction cosines of a straight line passing through 2 points. Now the next example you can learn from the textbook. Next, third example. Actually, second example is, if the DCs of a line, are proportional to, just now I explained this point, if the DCs of a line are proportional to 1 minus 2, 1, find its DCs. So you may think DCs are given, find DCs like that. No, DCs are proportional to. So that means what is given? You are given that the DRs, they are proportional, so they become the DRs. So the direction ratios, given that the direction ratios of the line are 1 minus 2, 1. So what are the direction cosines? Therefore the DCs are, just now we found 1 by root of 1 square plus minus 2 whole square plus 1 square. So, and then comma, minus 2 by 4, 5, 6. So root 6. 1 by root 6. So like this we'll write. Here also I'll write root 6. So these are the direction cosines. Okay. Next is show that the line joining the points. Third example, show that the line joining the points, P0, 1, 2 and Q 3, 4, 8 is parallel to the line joining the points. Is parallel to the line joining the points. Is parallel to the line joining the points are -2 and then 3/2 -3 and S is equal to 5/2, 6 and 6. So I must show that the line joining PQ is parallel to the line joining RS. So in the solution you write all the points and then you write DRs of the line P. First you write all the points. Given P is equal to Q is equal to R, write all the points. After that you write DRs of the line PQ are x2 minus x1, formula is x2 minus x1, y2 minus y1, z2 minus z1. So when you just subtract, x2 minus x1 is 3, y2 minus y1 is 3, 8 minus 2, 6. So these are the DRs. So you name them as A1, B1, C1. Now again you find the DRs of the line RS. So they are again x2 minus x1 like that. If you take, it is 5/2 plus 2 and then 6 minus 3/2 and then 6 plus 3. 6 plus 3. So what is it? This is 4, 9/2 and then 12 minus 3. 9/2 and then 9 like this. So these are your A2, B2 and C2. So you found A1, B1, C1 and A2, B2, C2. When are the two lines parallel? When A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Now we'll just find out. Now A1 by A2 is equal to A1 by A2. What is it? 3/9/2. 3/9/2. That means 3 into 2/9. So that is 2/3. Now we'll find B1 by B2. This is also same. B1 by B2. What is B1? 3. 3/9/2. So same. 2/3 only. And then C1 by C2. C1 by C2. C1 is 6. C2 is 9. So 3 2s are 6. 3 3s are 9. So you can say. After this you write, this implies A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Implies the lines PQ and RS are parallel. PQ and RS are parallel. So like this we do the problem. So to show that two lines are parallel, show that their direction ratios. First find their direction ratios and then show that they are proportional. Okay, next problem is, next one is again similar to this. You can try. Same 4 points are given. Show that they are perpendicular. The lines joining AB and CD are perpendicular. It is the 4th example. So if the lines are to be perpendicular, then you must prove the condition A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Okay, I'll just give that problem. Show that the line joining the points. Show that the line joining the points A 2 3 minus 1 and B 3 5 minus 3 is perpendicular to the line joining the points C 1 2 3 and D 3 5 7. So you can take this as homework. So first to find the direction ratios of AB, direction ratios of CD, and then you will show that A1 A2 plus B1 B2 plus C1 C2 is equal to 0. So it implies that they are perpendicular. So like that you conclude. You can take this as homework. Now we'll continue with the problems in the next period. In the next period, we will be doing all essay type questions first. They are very, very important. From this chapter, we will get one essay question. No? So first we'll do essay problems and then do the remaining bits.